Hello everyone, welcome to my channel. Today we are going to see the basic configuration of Unity Pro software. Schneider Unity Pro software helps us to configure the PLC such as M340, M580, Premium, Quantum and other X80 series PLCs. Double click the Unity Pro software. It will take little bit time to open the software. Once it's open, you can see now the Unity Pro software menu. Now you will see first one, file. From the file you have new, open, exit and some example files. And you can see here status bar and output window in view, and tools you can find basic library, DTM, audit tool, customized and option. In PLC you can see connects, set address, standard, simulation mode and backup, project backup and end. So now first initially we will just check the demo files of Schneider 1 which is coming as examples. So just click open. From here you can see three examples: demo, Unity Pro, M580 and 340, M340 and out standby for M580. Here if you click M340 you can see the basic detail. Example of the project information, what they have named, injection molding machine, Unity Pro XL version 13, and type, this is the processor type and when they modified, and this project is used for offline project, that means old application is only for demonstration purpose. And if you go for Unity Pro M580, you can see which processor they are using, similarly for on standby PLC. Now we will click Unity Pro M340 for checking the details. Just open, double click this M340, it will open the file. Okay, now the Unity Pro M340 PLC demonstration is open. You can see the redo, it can be only read only. Okay, here you can see injection modeling machine, and from here any of the PLCs, initially you need to make the configuration for hardware section. See here, this is the hardware section in the Unity Pro. Here it will come under the PLC bus. Okay, here this is the hardware section. If you double click, you can find the hardware section of each one. Just close this one. Okay, this is the basic hardware configuration with rack, power supply, CPU and some IO cards. And if you click each one, you can find the details. This one we can see in our basic hour design configuration. Initially you just see the basic designs only. This hardware configuration, and here they have some derivative data types already created for this demonstration purpose. And in derived function blocks you can see some function blocks they already created for this section, for this demo section they already created for demonstration for this injection modeling machine. And if you go below, you can find the variable and function block instances. Here you can see some instant variables which they created earlier, and you can see this is elementary variable. Here you can add what are the variables you need, you can add here, and for here derived variable blocks, it's already created here for derived and it can be used in many places. This one we will see in our configuration time. And also for this one, device DDT variables, IO derived variables, elementary function block variables and derived function block instances. These all already have predefined from the variables and function block instance. And here they used for motion control also, for motor. There is some recipe they are going to control here. And if you see in the communication, you can configure the network for the communication as well. And the next section and important one is program. Here you have tasks. If you see here in the program, you have two tasks. One is must and another one is event. Okay, in the task. Okay, in the must is master one. Okay, here you can create many sections, and if you see one example, they already created for some start and stop process for the machines, and here they make some examples. This will come default from any. If you install the Unity Pro software, you can find this one as default. These demo applications. See, here they created with many languages. This is, you can find here, ladder diagram. This is structured text, and this is function block diagram, and you can see instruction list, and here you can see sequential flow chart as well. And this is below the program, you can see animation table. Here in this animation table, they already added which one you need to monitor for animation, and here you can monitor and force the values in the animation table. So they already added many of them, for example, and they also, we can create here the operator screens. One of the beautiful of Unity Pro compared to the other software, here you can create new save like HMI. Here you can monitor and control the system as well. See here, this is the example of process overview, and here they already created for process control screen, waiting, feeder, heating, and forming, packing, etc. And you see each one, they have functions. Then you can monitor the values, and you can even control the pumps, everything, without even if your project value is very less, you don't need to add the SCADA system. At the time, you can use this one as SCADA also, these operator screens. And from below these operator screens, you have documentation. In this documentation, you have title page and general information. See here, you can add some general information of the projects as well. And even you can add some bitmaps and some files to download to your application in your controllers. If you need to add some files or backup, you can add from this documentation as well. Okay. Now we will close this demonstration for demo application, and we will create one new application. Click here and give new. Here it will ask you which PLC you need to be add initially. You have, I already informed you before, you have M340, M580, Momentum, Premium, and Quantum. In M340, you have different types of CPUs, and based on your application, you need to be select that modules. Example, if you need to use your CPU or your application for Modbus, you can use these two for basic Modbus. If you need to use for CanOpen, you can use these two modules. If you need to use for Ethernet, Modbus Ethernet, you can use this module. And if you need to use for any remote I/O adapter, you can use this CPU. This is for M340. Similarly, you have for M580 as well here. See here, this especially this M580 is mostly replacement for Quantum PLC, because the M580 have written hot standby PLCs as well. You can see here, even the basic module, you have hot standby, remote, and distributed IOs. Same for BME H584040. It is used for hot standby and remote. With if you compare this between these two, the processor is here very high capacity compared to this one. And you can use even 6040 and processor, and also if you need to use without hot standby, you can use this one for distributed IOs, these models. And if you compare these two between this M340 and M580, the part number of M340 is BMX and the part number of M580 is BME, and it will be started with H, and here this H is hot standby and this is processor, normal processor P. Similarly here BMX P34, this is the part number of each one, and this 34 is similar for M340 because this 340 M340, so they use processor 34, and the last digit 0 is become 1000, 2000, 2010, 2020 like this. And similarly for M580 also BME H58 2040, and if you see that this last digit instead of 0 it will become these digits like 202040, 4040, 6040 like this similarly. And now now in Schneider, if you see in this current trend, they are using M3580 and we are using M580 for most of the application because this is very compact. And now these tools it is using for latest technologies, and for small application you can go with M340, and for larger application and for hot standby or any critical application you can use M580. And similarly you have other modules here. Momentum it's we used maybe 15 years before, and now it's almost absolute, but still they have some IO cards. It will be used for, I told you before, X80 series also. And here you have 3 different modules. 171 CBU, it's a model for Momentum PLCs. And if you go for premium, if you double click the premium, and you can find many processors. Premium, it can be used like TS6. The model is TS6, and it is similarly same hot standby. H means hot standby and P means processor. They use this much module for premium. In premium, we use different types of protocols supported earlier, like Unity, CANopen, Unity Railway, FIPO, and Ethernets, etc. And also for quantum, you can see different types of model. In the quantum, it will be used for 140 CPU, and it will come the processor names, numbers based on your requirements. Earlier we used the hot standby from this quantum. See, you have many functions, hot standby, and this is the capacity 1 to 1024 KB, and PC, MCI, this for serial connections and third-party connections, and you used for Ethernet, hot standby, fiber optic, USB, Modbus and Modbus Plus. If you see, if someone is going to select the processor, you have now you have different processors. How you will select? If someone they need with basic Ethernet only, with Modbus and with low cost PLCs, you can go with this one, M340. And someone they need to connect with CANopen also, you can go with Modbus CANopen. And if you need to go with some standard with high density PLCs, you can go with M580, and you have hot standby with distributed IOs also. If you need to connect with remote IOs, you can go with M580. And if you need to go with any PLCs which supports Unitel Way or CANopen, FIPO, even CANopen it will support up M340 also, but for premium you can go with Unitel Way and CANopen. They used in older technologies here, so they go with premium earlier. And for quantum, these two, premium and quantum, we used in olden days, not now, because this almost quantum is absolute now in current situation, and premium also it's almost absolute now. So this two is replaced with these two technology, M340 and 580. So now just what I will do for simple application, I will use this processor, because this is one of the best processor we use in many projects, BMX P342020, because this one have Modbus, Ethernet, and also serial communication, and this is very basic processor. And if same time you can select the rack. See here you have many racks. Just select one of the rack. Example, now I will select this one, BME XPP. Here rack also, BME means Ethernet backplane, BMX means normal backplane. See your BMX, it's normal backplane, and BME means Ethernet backplane. I will select these two and I will give OK. It is generating the software like configuration now. See, before moving here, just I will explain initially here what you need to do. This is the basic setup for new, open, and save as. Okay, now I will see, initially you have no name. What I will give save as, and I will give one name. This is for test. Just give test and give save. It will save the file. Okay, once it's saved, it's become saved, but it's not built. Okay. So you will see this one all, and if you need to export this file, just give the name. If you need to give the same name and give export, it will export to zip file. And these things I will come later when you are exporting, and you can export with .xef or ZEF. And here edit, this is just to add the user dictionary and add hyperlink, go to, and properties. This is not very important for us. And for viewing this property like blocks. Example, if you click functional block, functional, it will come to you this one like a functional view. And if you need to make both together, structural view and functional view, you can click here. And you need to make it horizontal, you can make in horizontal also. Currently I will use this one, only structure view. And for services, when you are making online, at the time you can make services to make animation here. And you can see here some useful things. Example, project browser. This is the project browser which we use here in the tool. Hardware catalog. If you need to add some of the additional modules from third-party devices or even from Schneider's, you can use here the module, basic IOs, distributed IOs, motions and drives. Example, you can use multi-watt drives here directly, and you can use motor controls from here, telesis, and motor control, motion control, and safety modules, sensors, third-party products. And also you can, if you click here PLC bus, you can find many options for adding these IOs cards, counters, digital input, analog input cards, motion control, motion cards, rack, supplies, third-party products, etc. See, and if you go for here DTM catalogs, you can find all the third-party drivers. You can find here. Even for connecting the gateways and for third parties and vendor, example you see AGM, advanced microcontrollers, back-off automations, HMS, HMS, you can see any bus controllers, and also you can see the Rockwell automation, Schneider Electric, Woody, soft electronics, and also you can see different types of protocol, CAN open, SIP, or Modbus over TCP/IP, etc. So this is for hardware catalog. And now we will go for types of library browser. If you need, you can check here after when we are using the project, you can find this one for types of hardware browser libraries. And this is for operator screen. Operator screen, when you are creating the operator screen, at the time you can use this function. And this for search and diagnostic viewer. Whenever you are in the online, you can find the diagnostic view here, and also for the PLC screens as well. And for variable windows, also it can be used during the editable time. I will show you during the time, and also for data editor. And DTM browser, similar to that hardware catalog, you can find example. Now you connected directly with your CPU, and you connected some third-party devices. At the time you can make the browse, and it will be automatically detected in the DTM browser. And trending tool, you can use during that operator screens, and when you are creating in online, at the time you can use this trending tool. And this is for conversion. And also network inspector, this can be used during the troubleshooting of the communication system. And for DTM audit tool, this one, whenever your configuration of example the hardware is not matching with you, it will show you your audit. If it is matching with that same application, you can it can be automatically add here. Otherwise it will show you the difference between your hardware configuration and the existing PLCs, and what is the difference, and it will advise you to import the files from here. Select the files, and you can add the file and check the configurations. And this is also types library manager. You can use here your lib manager. Here you have all the functionality. This is very important one, actually, types of library manager. You can find here all the functions in your application, not in your application, in the software itself. You have all the function libraries here, so you can find one by one. See, if you need to add, you can add this add function, add byte, add boolean, for add boolean, add integer, add real, everything. And even you can make add function, and you can see all the function here: byte, counter up, counter down, date, decrease. You can find all the functions here: timer or timer, counters, word to integer, integer to bit, or anything what you are going to add in the function, because they have a basic library. From here you can find all. You can see here by separately also arrays, CLC, comparison, date and time, logic, mathematics, statistics, strings, timers and counters, types to type, communications. And in the communication you can see all the communications, like example how to exchange the data from one parameter to another parameter. Control, content control, custom library. Custom library, you can add your functions. Example, you already created some own functions, you created some own blocks. At the time you can import, and you can keep here in custom library. And some diagnostics, they have some diagnostics also you can add here. And also you have IO managements, motion function blocks, motion, safety, etc. So you have different all types of library managers you can find here. Now we will move to another one, customize. In this customize, you can keep what you need in your toolbar: file, edit, service, application, window, help is the one basic. If you need to add additional like debug, watch point, you can add these two also. It will be added here in the menu bar. It's not very important for us. And this option, Here this is very important, because here if you need to create where you need to save the default program, where the project path will be default, it will be created. You can change these paths. If you click, you can change the path directly. So I can keep here all the default, and here it will ask you the date and languages also. If you need to change some of them points, you can change from here. You have up, down, right, left, move the selection for entering information, and also open edit session. On character key press, like you can keep all same default. See when you have what are the functions you have as per LL 984 language. You have these functions. MO means normally open contact, normally close contact, and all the functions you can see from here. And here in the connections you can see my where it's connected. My PLC connection identification is my PC name, and default connection mode is use programming mode. You can keep almost this one also as default. See here in the concept, here even you can convert from this concept or concept PLC or PL7 software PLCs. You can directly convert that application to Unity Pro. At the time you can use this option. Now we will move to the very important things is project setting. Here it's where if you don't know how to modify, just keep it the same. Sometimes you will feel there is some problems. At the time you need to check in the project settings. Example, you see variables not used generates. You need to give nothing, or you need to give warning. If you not use the variables, you can give warning. Example. So if you know these things, you can modify. Multiple writing of variables. If you are using your variable in multiple places, you don't know, maybe it is something overlapped. At the time it will not give nothing, it will give you nothing. But at the time if you need to know that one, you can give one. So it will show you it will used many times your variables. So you can check one by one here. DDT mapping, compactable generator, you need to make warning. Overlapping the address generators, if you give the same address 2 times, it will give you warning. If you don't need, or if you need to give this one as error, give error, or you can give nothing. Okay, same for missing gateway IP generates and warnings, and maximum of warning allowed is 500. You can add or reduce this one. So if it's go more than 500, the program will not execute. So you can reduce this one or keep it the same. Same for error also. The maximum of error allowed is 500. So you can add or reduce this error in as per your application. And for build settings, you can give this one, create new block online. You just click, it's as default, it's used as clicked. If you don't need, you can remove that one on online. Generate with LD linked animation, yes, it's created, yes. If you don't need, remove this one option like that. So you can check one by one. Automatic saving, yeah, here it will be whenever you download the application, it will save the file as STA. You need to save as well as STU also. Double click this one, so it will be save .stu also. If you need to save .xvm, you can click this SVM. Okay, during the time I will explain to you during execution time. Okay. Just now I clicked for time being, I clicked save.stu, I clicked OK, yes. And here data dictionary, if you click, now currently it's no, and only for variables. See, some of them it's disabled because you did not enable. If you enable this function, it will be, you can modify this value. And you upload information, yes. If somebody is in the controllers, you can upload the information now. If you don't need to upload someone, like the complete information like commands, animation, table, everything, you just remove this one you cannot able to upload your informations, and even you cannot upload your commands or any animation tables from the controller to the PC. Or uploaded information management, it is default, it is automatic, even you can change to as per user request. And optimize data on line change, currently it is not enabled, you can enable this one also. And now we'll go to PLC diagnostics. From the PLC diagnostics, application diagnostics, its default it is without. If you need, you can click and you can change this value. Similarly for rack and program viewer informations and event logging. And for PLC behavior, example, it is reset from %m on stop to run transaction. Click this one, so it will be start for run. Currently it is no. And also for path, time, and you can see for configuration, M5, this is for only used for M580 data types with local IO and quantum EIO. And for variables, you can change some types. Okay, similarly you can go with program, you can see the procedures, allow the procedures, allow subroutine, and if you allow nested commands, you can just click if you need to add. And use check, you can use during the execution time, you can see these functions. See, for FBDs in one of page, you can use number of rows 240 and number of columns is 360. If you need to increase, you can increase in one page. For ladder diagram, it is mixed display, just telling that command height 1, symbol height 1, and also address line height is 1. If you need to change, you can add 2 or 3 like this based on your application. And for SFC, the number of active steps, it's 32, and number of action per section is 96 maximum. If you need to increase, you can increase for default. It will be affecting the complete application. So similarly, these all functions, which one you need to add, you can add. Currently in this application, I add for save function only. For this one, I give auto save and I apply and give an OK. So we completed these two tools. Now for build. Currently it is, see, it is not built. So if you need, I will just give analyze or rebuild application. See, analyze, it is analyzed. After I analyzed, I will give you rebuild. It's built right now. Now, and this application, these other things, whenever it is not built, it will show you this enable. Now it's a completely built, so it show you it is not enabled currently because of it's built already. For this PLC, this very important section here, because you have connect, set address. For connect, it is going, if you click connect, it will connect to your PLC. Okay, now currently you don't have, I will show you in coming time. For set address, you just click the set address and you can see here PLC or simulator, because it's selected now PLC. Okay, here you have many options. Here you see media, you are using USB, you can use with USB or United Way, TCP/IP, Modbus Plus, etc. If you need to use now from TCP/IP, just click TCP/IP and change your IP address, so you can communicate through this TCP/IP to your controller. Okay. Currently, if you need to use directly with USB, give USB and give SYS. For USB, you have to give SYS. Okay, this is default. And if for simulator, already in the Unity Pro software, you have auto simulator. For the default address of auto simulator is 127.0.0.21 and it is TCP/IP. Don't change this one because this, usually it will be fixed and it will be work directly when you click the simulator. And now you need to test your application, like your direct address test connection. It will show you that target controller is already connected successfully. If it is not, it will show you there is no valid PLC address or PLC PC or media is off. This means it's not connected. Okay, if it's connected, it will show you the target PLC is connected with your PLC, and it will show you tick mark. Okay. Now we will go with for the standard or simulator mode. Here, this is standard mode, this is simulated mode. See, once I select simulated mode, it will ask you confirm to change to simulation mode. Yes. Once you give simulation mode, you can find here it is simulator. It will work with simulator. So now for default I put standard mode. And these options, whenever you connected with your controllers, you can see these options are like compare, transfer project to PLC, transfer project from PLC, and transfer project from primary to standby PLC, save data from PLC to file, restore data from PLC file to PLC, safety maintenance, run, initiate, everything. It will be when you connect in online, you can see this enable of these functions. And this is for backup, and this for memory consumption. Currently you can find what is your memory consumption in your application. The data, you can see this blue color is data, and this light blue, you can see declared data, this one 1.6, and you can see unsaved declared data, this one. So you can find user data, user program, and others, how much you use in your internal memory or with memory card. Currently this memory is available freely because you did not still not use any application. This is default. And for debug, also when you connect the PLC controller, you can find all these debug functions also. And for Windows, it is normal, close Windows, close all windows, keep active Windows. And for help, you can find the like something, if you have doubts, you can go with the help, and you can find and you can search what you need in this application. Example, what is the system bit? So you can find here help files. So this help file, mostly you can find most of 90% you can find from the help file itself. If you have any clarification, you can find from the help file. And now we'll move here to the project browser. From here in the structure view, initially it will show you the project name, project. See, now I will give save, like save. The project name is test, and here initially it will be have the configuration. Okay, the configuration, here the main section is configuration. After you configure the hardware and every sections, it will come to the variable sections. In the variable sections, you have to add all your tags, IOs, everything here in this variable data editors, in this section variables and function block instance. After you complete this one, you have to configure the communication of your network. Then the next stage is programming section. From program, you can add here all your what are the programs you need here. For basic applications, you can add here. After you make this, this animation table is used to add all your animations in your project. Example, you need to make so on or off this the symbols, or you need to simulate the IO signals. You can simulate from the animation table. You just create all at one time, and you can save the animation table. After that, you can add to monitor and control the IOs. And operator screens, I already informed before, you can add some additional screens to monitor the system, monitor and control as well. Now we will move to this configuration section. First section, here just click this any one of that rack or power supply, close this one, and you can find here the basic configuration which we selected earlier. Now the base earlier I selected with 12 slot, see BME XPB 1200 12 slot Ethernet backplane. So just click this one and replace if you need to replace with another backplane. Example, now I am going to make with 8 slot Ethernet backplane. Click that 8 slot Ethernet backplane, it's added here. So if you need to modify the power supply, go here, delete the power supply and add with higher one, example 3500. You already added the 3500 power supply and check the processor. This processor, if you need to replace the processor, and replace. It will ask you the warning, because if you change the processor, it will be change almost all your history. Even sometimes the application, it will affect the application also. So it is giving warning. Currently I am using the same, and this is your memory card slot, and this is for Ethernet, and this is for serial. Okay, now I will change. Example, now if you need to add some Ethernet port, click QTCP/IP, and currently you don't have link, because once you configured here the communication port here, after that it will come to you link for this one. Currently you don't have project, so just I will close. Yes. Now for this one for serial, this port. The serial port I already told you before. You have two, RS-232 or 485. You can select any one of the options, and you can communicate with the third party master or slave for any power meters, or even you can use for any third party devices from this serial communication for Modbus. Okay, now we are going to add one by one cards. Initially I am going to add one new device, DI. Example, once I click, you can find this one for analog, communication, counting, discrete, motions, and third party products. I'll go with discrete, and I can select this module, same name of the module. I already explained in my previous videos for basic PLCs. From there I already informed that about source, sink, transistor type, relay type, etc. So here you can see this, see in each module you have these different types like sink, source, relays, transistor, etc. So I will select one. I will select for default, I will select any one of the module. Okay, 32 DDI 3202K. I added one module, and I am going to add one DO module, DDO. Okay, see, okay, transistor or sink module, sink or source module. Okay, I will add transistor source module 0.5 ampere, and I'm going to add one analog input card. The default I will add this one, BMX AMI 0810, because it's 8 channel isolated ID speed. And I will add one analog output card, BMX AMO 0410, and this is 4 channel analog output card. So at initial stage you added one DI, one DO, one AI, one AO card. After you add, just give save. So you complete this part. Okay. After you complete, as I told before, you can go with variables to create these IOs here. Okay. So the address format for any PLCs, first of all you need to understand the IOs. Okay, here see, if you click, you have example, if you have 32 DI card, it will be divided into 8 channels. See here 8, first 0 to 7, 8 channel, and 8 to 15 is another channel, 16 to 23 is one channel, and 24 to 31 is another channel. So it will be divided into 4 channels, and you can see, you can select each channel also. See, example for 0 channel, it is masked, and everything is initially it is having masked. Even you can make as fast also task, and supply monitoring. Okay, now how we will find the address of these cards? So if you click, you can just see only the controllers. Example, you see for DO card you have program for reactive, and you can make in automatic or fallback. Reactive mode programmed or automatic, and fallback mode you can make fallback or maintain, because fallback in case of the communication fail, if the power fail and it will be again, it will restart, it should be maintain the same, or you need to make to 0. Example, what you put at the earlier stage. So if you put fallback, you can put either 0 or 1 at initial stage. You can select these things also here. And also you can see the complete module feature here for each one. Example, overview of that one, of the DDO module. You can see the specifications, and also the LED. Example, if the LED is continuously green, it is normal. If it is red, means internal error or module failure. IO, it is IO red, means it is short circuit, etc. So you can find even the 0.5 ampere and channel properties, its protected and maybe isolated, it's configured, and IEC conformity is yes, like. And for memory you can change this one, but before doing this one, you just click at the earliest stage for the CPU. See, now you here, and you can find all the properties also. The topological you can change from here itself at initial stage, topological or mixed topological state. So you can select from here itself, and even you can put initially it will be on cold start, or cold start with only or memory protect. Everything you can configure at default. And for animation table, during that runtime you can see this value. So now we'll go for analog also. See, you have analog channels, and you can select which one you need, 0 to 10 volt, or 0 to plus or minus 10 volt, 0 to 10 volt, 0 to 5 volt, and 4 to 20 milliamps, 1.5 volt or 4 to 20 milliamps. I will select as 4 to 20 milliamps, or 0 to 20 milliamps also we have option. We have many options. This one will be selected by program itself, and I am not going to use, so I will remove this one. And also for scaling, you can put example what you need, 0 to 10,000. See, it is below 800, it will show you like overflow, like less than minus 800, it will give you failure. Above 10,800, it will give you failure. So you can change this value by adjusting by yourself. Currently I will keep the same for everyone. See, everyone you have that one, 0 to 10,000 for 100%. So I can keep the same, and I will give same. Just telling that it is already saved in current setup, and you just click here validate. If it's validate, means it will be saved for the hardware configuration. Same for IOs. See, now for everywhere you already made, but you don't know where you can find your address. See, now for similarly for DO, just I will select 4 to 20 milliamps for each one, and I will save. So I will find the analog input channel properties here, and I have all the IO objects. Okay, now I need to find the address of each module. What is the address of example DI? See, I cannot find here, so I just click here. I have overview, memory, and here. Example for DDI 32 channel. What is the address? Just click here, update grid. You can find your address. See, this is your address, percentage I0 I0.1.0 I0.1.1, similar up to I0.1.31. So this is your first channel address. Okay, so if you need to remember this one, percentage. How you will find this one? Percentage I0.1.0. See here, percentage I0.1 dot channel number 0. So it will be similar for channel 1, channel 2, channel 3, like this. So you need to first identify how to make the addressing format. Okay, without this one you cannot do exactly the same address. So click here. I need to add name. Example, first one, pump remote. It is Boolean. Then address format, percentage I0.1.0. So just I will save. Click this one again. Check, it's already added. Okay, you can find even here. Pump remote. So your first address is added. Similarly, you need to be add for some address, like example pump underscore run percentage I0.1.1. So you can add for 4 signals now. Pump trip. So copy and paste with true. Period pump local. So you add one pump signal and you can find all this here. See, pump remote run trip local. Similarly, you need to be add for DO also. See here, you need to be check. Already you check with percentage I input. Now you can go with output. Click update. Percentage Q0.2.0. This is your address for digital output. So you need to configure this address here. Add your address, pump underscore start command. Percentage Q 0.2.0. Okay, just give and check in your module you added your DO address. I will add for analog input as well. Here, click here, go here and double click, click this one, percentage IW and upgrade. You can see percentage IW 0.3.0. This is your integer value for analog input, first one. So I will click here in data editor. Now I will put for level, tank level. So here I need to change that type. Click this one. and you can find many types. Now in the variable level, click this one and you can find many options like any bool, byte, date, double integer, select integer. Click and you can give the address. The address I already told you here. Click your module AMI and from here click IW and upgrade. So percentage IW 0.3.0. The data editor percentage IW 0.3.0. So you added already for DO, similar for analog output. Okay, now I am going to control one MOV percentage command, MOV analog or speed command, or pump speed command better. Pump speed command. So here I will add percentage. Before adding this one, you have to confirm your value. Just click here, percentage QW. Here IW, it is QW. So if you need to check the value, check here, percentage QW 0.4.0. So add here percentage QW 0.4.0. So you already added one sample signals for each one. So this is the first step. You are adding your hardware configuration and you created one basic IOs for this. So here this all address format which you selected, this one will be based on, see here the selection. If you select here the CPU, I told you already the configuration type is different. See here topological or mixed topological and stator. So some of the address for M340 you have to give this type of things like percentage I 0.1.3 like this. But if you go for M580, it is totally different. It even you can give the address format like this, or it will be take by internal address, because it will be make a connection directly with HMI or SCADA system by default. So they have different formats for each address in each devices. So this tick mark is all. This means it's not built. Okay, so you see now like this one or tick marks. This means it's not built. So I am saving the application, and you can give either analyze, even you can give direct build also. Still it's not built because it's giving error. So I can find what is the error. See, the topological is incompatible. Okay, just I will click. It is telling that it is incompatible. Why it is incompatible? See here you given this one as boolean. Boolean, it will be used for internal memory as well as for some DI. For physical address, you have to give eBoolean. Click, select eBool. Same, similar to this. Second one, give eBool. Even if you type, it will come to eBool. Select all eBool. now you selected all equal and save. Again you make a rebuild. If you need to analyze, or you can give direct rebuild also. Rebuild. See, now process succeeded with 0 error, 0 warning, and you can see here built. This means now your application is 100% ready with hardware configuration and basic variable what you already made variables is working. Okay, now these two sections we already covered. Now we will go for basic program. Before going this one, just make sure that you need to know the basic PLC languages. So you have totally 5 basic languages. I will show here also. Okay, close this up, this order configuration and everything. And even before going this program part, what I will do, I will configure one of the communication network, because here still I did not configure the communication network before. See here, this Ethernet, so it's not linked. So what I will do now, I will add one network, right click, give new network, select this one, Ethernet 1, give 1, yes, it will come give one network line here, and here just give one IP address for default 192.168.0.1. Okay, here I will give you 255, here I will give you 255. And before doing this, check this one, because it is in NOE module, so you have to select either this module or this CPU 2030 with version, or you can give you I greater than this version. Okay, change this name family, change network family, some data values, and after changing this, activate this. It will like some data for services, yes. So you changed. Okay. Once you changed, check now. You have Ethernet link. So this is how here you need to connect your Ethernet link by this, through this configuration of network. So you completed almost the configuration part, how to make the data and how to make communication. Now we will move to program section. Here you have tasks and events. In the task you have masked section, SR section. In the events you have timers, events and IO events. Now usually whenever you are making the basic program, you have to go to sections in the master. So just click this one and make right click, and you can find new section. Just click and give any one of the name. Example pumps. Pump section. Okay, here the language you can find different types of language. ST structure test, instruction list, function block diagram, sequential flowchart, ladder logic, LL984 segment. Now we will move to, initially we will move to ladder logic, and you have protection also, like in case if you need to protect your program by read only, or no need to show anyone for read and write, you can select here. So now default you can give no, and you can localization you can give master session, and even the function modules you can change later. And for conditions, these are just names only and commands. Usually just give the name and give apply. Once you applied, it's already created here. double click this pump section, pump, and here it will open the blank menu. From here you need to make the program. Okay, now where you will find the once you create the ladder logic, you will find the supporting files all here, like example selection mode, escape. Here normally open, normally close, and also positive transition and negative transition, and also you can find the coils, negative coil, set coil, reset, and also positive transition coil, negative transition coil, and also halt coil and call coil. And this one you can use for connections for boolean, and it is vertical connections, and this is the link between the big connections, and this is for operation, and this is for compare block. And also some other functions you can use here: jump label, return, and these functions you can use for data selections. And also this one is link and toggle pin, etc. Okay, you already make. Now you need to start with one small logic for the pump. Just put normally open and one normally close contact, no trip, and the pump should be healthy, and it will start the pump. Okay, so now I need to make here boolean expression, and if you browse you can find your what you entered earlier, the variables. Now I will enter the pump remote. Just view. See, if it's not entered before, it will show you to create. Okay, if you don't know the address, see, just click and you have here browse. If you browse, it will show you default. But now see, just what you created here, everything will be appear when you are making browse here. Okay, but now my case, just I will give remote. See, it will appear, and pump no trip, pump underscore trip underscore. Okay, so now and here I will give you pump empty, pump underscore HLTY LT. So when I create, it will ask you to create a normal boolean, or if you need to make address you can make, but I will use as now internal memory healthy. Then this one I will give you pump command, PUMP str underscore command. So this is my basic ladder logic, and from here when the pump started, I need to be run continuously. Therefore you can make in latch, or you can make by year 2. When the pump starts, you can put that condition here, so it will be continuously start until the signal will off, same like how you are making in MCC relay logic control. So now the pump started. Now when the pump should be stopped, there will be condition the pump should be not in remote. This is remote, and the pump should be either trip, the pump is trip, and also no healthy. Pump is not in healthy, and the pump is trip. If any one of the condition, the pump will reset the command. So just I will copy this one and you paste for reset. here pump remote, no pump remote, and also pump is not healthy, and the pump is strip, this condition. So the pump is strip, it will be off automatically. See, if any one of the conditions satisfied, it will automatically reset the pump command. Just I need to make link between this. So I complete one basic steps. Save, compile, build this logic. Let's rebuild the project instead of generating our modification. Continue. Okay. So there is one warning. It will not affect our application, but even though I will check what is the problem. Just I'm checking. The network is not linked to a model. Okay. Check, maybe it is already linked or see not linked. So if not linked, link this one. Save, compile, see. And there is one more error, that security is not enabled on this model. Please ensure the firmware of real model supporting this feature. Okay, it's telling from this version. So this is just like warning, it will not affect you. So you will, no issue, it will not affect anything now. So you already configured, because this one only for security. So you make elementary variables and you created one small logic. Now we complete the basic section. We will move to check one case study or case examples. So I will close and open that application. That's what I will do now. I will save. I will close this application. And I will try to open one example application which we created for the earlier project. Open, it is in the desktop. See, if you open the same, this is STU application. If you keep the same version, you can use the STU. See, you have different file types. ZDF is full application exchange files, and XEF is application file. If you have different version, you need to use this any of the two version to import the file. And this all you can import, and you can see this is PL7 file. You can upload, import from, migrate the file from PL7 to here, and also from concepts, from the ProWorks, and from the PL7 data, etc. So now what I have here this zip file, and I will search the file. See, this is my file, main PLC. I will open this file. So it is importing the file. It will take little bit time to open the file because it's importing the complete application from zipped. It's already zipped, so it's opening the zip file from the Unity Pro application. Here, this is one of the example project which we worked before. This is one of the RO plant, big RO plant application. So it's taking a little bit additional time to open this file. See, now the file is opened. And you see here you have remote IOs, remote bus also. This means remote IOs. See this one used in quantum. See, this is the quantum CPU 140 CPU 67160. This hot standby CPU. See, if you check here, you can see this is for hot standby configuration. And see here hot standby CPU with Ethernet, hot standby fiber optic, USB, MP, Modbus and Modbus bus. That is the PLC CPU model. And here it's configured with CRE MOE modules, and it is configured through remote bus, remote IO drops. See, in each remote IO drops you have many IOs. So you have we use almost 4 remote IOs in this drop. And see here the logic also is very big. So you can see the sections, there is many sections, all we created in function block diagram. So initially these initial steps, and we make for our standby configuration, and this is for PLC moving the communication bit from this for diagnostic purpose. It was moving from to find the communication for healthy primary standby fault indication everything. And here we have ROs. There is 4 ROs. Each RO you have the data, raw data from the PLC, and we are going to transfer it to the SCADA system. See, therefore we use here bit to word to transfer this data to the SCADA system. From here we are taking from the PLC baud value, and its color we are changing to bit. You can see the many runs, and we use some blocks for level transmit, like for analog scalings. We use analog blocks also, transmit scalings. So these functions, example, this block, how we will make. Okay, therefore we need to see this all in very depth on the next session, but I will show here how we made. See, TX scaling. TX scaling you can find in here derived function types. Here you can find TX scale. See here. See, these blocks already derived one time, and it is used in many places. TX scaling, TX scaling. See, if you see the logic of that one, you can find here. This TX scaling language. See this one. You need to create one time one function, and this function will be called in many places. So this one we are telling as derived function block. So if you see here, we made many derived function blocks in this project, and we use for P&ADs, duty standby, recovery, RO recovery, and also timers, and also for scalings, for analogs, and for walls. See, if you see here, you can find the wall block. You can find the logic of the wall. If you make for one wall, it will be duplicated for many others places. So use as a function block here. So this everything is very depth. So we can see in the next session, because this will take a lot of time to create. I need to explain with basics, so it will take a lot of time to understand from your side also. So just I will show you here one samples only. And these derived blocks you have to make here derived data types, and here also you can create some data types. And this block detail, so you made already derived blocks. Okay, these derived blocks you can find all the detail here. See, TX scalings here, derived FP in here, FP instances. From here you need to find these derived block addresses, the complete TX scaling. Here you can find all your IOs. If something is, if you are adding in your logic here, in this logic here you have to first create in these data variables. Okay, you need to be add inputs or outputs or input output values from this place. Once you add, then it is easy to create in these places. See, open feedback, it is input. You can find the same open feedback in your input. This is for input output. This is for valves, sorry. This open feedback from the valves. See, we will open here scaling, TX scaling. This is TX scaling. So you can find here raw, out min, out max. You can find this data here. Scaling. You can find raw, in max, out max in these places. So you can find what are the tags you are creating here variables. You can use that same in your application in this place. So I will show you in the detailed programming section how to create these derived function blocks, and also we will see one by one languages, how you know what is FPD, how you use the FPD, and what is instruction list, how you can, and also for structured text, ladder logic, and functional block diagram, as well as sequential flowchart. So this everything we can see in the next session, and also we will connect the PLC program in the controller, and we will verify the signals, and even we can make the troubleshoot of the connections and also the IO signals. Also we can see the animation tables, how we can animate, how we can modify the signals by forcing the values from here, like for on off, and also the values of analog signals by set points. Everything we can see in the next section by clearly, and also we can do the operator screens, how we can add additional operator screens by creating some new screens, and how we see here you have the pictures also. You can import the pictures here by push buttons, and also some drawings like for pumps or walls and colors, animations, everything we can make in one session, and I will explain to you the complete detail of the Unity Pro. So thank you for watching this video. We can see on the next part soon. Thank you.